Okay, page 1064, chemical properties. Chemical properties describe the chemical nature of a material and the behaviors and the interreactions that occur at a molecular level. Let's talk about flammability. Most hazardous material incidents involve flammable materials. Flammable materials can damage life and property when they ignite or burn. The use of hazardous flammability to determine the incident strategies and tactics. These terms that we're going to go over, some of them are going to be familiar and you're going to definitely need to know them again. You must know flash point. You must know this: the minimum temperature at which a liquid or volatile solid gives off sufficient vapors at its lower explosive limit, also known as the LEL, to form an ignitable mixture with air near its surface. That is the minimum temperature. That is a flash point. Doesn't mean it's going to keep burning. That just means it flashed. Do not confuse flash point with fire point. Fire point, that is the temperature at which a liquid or volatile substance gives off enough vapors to support continuous burning. So what we're getting at is it's probably going to flash first, and then it'll get to the fire point where it continues to burn. So just know that. Make sure you know the difference, flash point and fire point. Only the vapors burn. The liquid or volatile solids that produce these vapors do not burn. The vapors burn. As a liquid temperature increases, it emits more vapors. If a substance is not at its flash point, it will not burn. Flammable gases have an extremely low flash point, so they are flammable at all the time. Autoignition temperature. Know this term. Autoignition temperature is a minimum temperature at which the fuel and air must be heated to initiate self-sustained combustion without initiation from an independent ignition source. Without initiation from an independent ignition source. That's key to that. I'm going to throw another term in there. Write this down. For autoignition temperature, the minimum temperature to when fuel in the air must be heated to ignite self-sustained combustion. The minimum temperature to when fuel in the air must be heated to ignite self-sustained combustion. Make sure you know that and write it down. I'm going to head down to flammable, explosive, and combustible range. Percentage of gas or vapor concentration in air that will burn or explode if ignited. Make sure you know that. Now we've got two terms here we must know. The LEL, also known as the lower flammable limit. Know this, that is the lowest concentration or lowest percentage of substance in the air that will produce a flash of fire when an ignition source is present. The concentration's lower than the LEL, it is too lean to burn. So basically, whenever we're looking for a gas and we're using gas detectors at a hazmat scene, one of the things we're definitely looking for when we might start setting up our hot zone is the lower flammable limit. If we hit a flammable limit and it alarms, we will know that between the lower flammable limit, it is too lean to burn. But if we go beyond that, we're starting to get into that right mixture where things will burn. So just know that the lower explosive limit or flammable limit is too lean to burn. The upper explosive limit, the UEL, or upper flammable limit of a vapor or gas, that means the highest concentration a percentage of the substance in the air that will produce a flash of fire when its ignition source is present. At higher concentrations, the mixture is too rich to burn. So, I've got the LEL, the lower explosive, the UEL, which is the upper explosive. So it's too lean to burn, it's too rich to burn. So in between those, that's when the mixture is just right. So those are the limits we're trying to avoid, is that in between, because that's where things will ignite on us. So make sure you know the difference in those two. Corrosivity. Corrosives are commonly divided into two broad categories. Again, we're repeating this from chapter 4. You must know the difference between an acid and a base. And you do need to know that a base is sometimes called a caustic or an alkaline. Make sure you know that. Some corrosives, such as hydrogen peroxide, are neither acid nor bases. So an acid, just need to know acids, pH levels from 0 to 6.9. From 0 to 6.9, and you can actually look at your chart on 1066 at the pH scale. Acids may cause chemical burns to the flesh or permanent eye damage. A base is water soluble. Know that, water soluble. Chemically dissociates in water to form a negative charged hydrogen ion. pH levels 7.1 to 14. pH levels 7.1 to 14. Now here's another key thing you need to know about a base. A base is sometimes, they say, is worse than an acid because it breaks down fatty skin tissues and can penetrate deeply into the body. They tend to adhere to the tissue of the eye, which makes it difficult to remove. Often cause more eye damage than acids. Common signs of exposures to an alkaline or a base: greasy or slick feeling of the skin, which is caused by saponification, the breakdown of fatty tissue. Remember, saponification was a term that you went over in extinguishers. So make sure you read those. Reactivity. Reactivity, know this, substance relative ability to undergo, relative ability to undergo a chemical reaction with itself or other materials. As a result, pressure buildup, temperature increase, and or formation of toxic or corrosive byproducts may occur. Reactive materials commonly react or violently act with air, water, heat, or light. Many first responders are familiar with the fire tetrahedron, or the 4 elements necessary to produce combustion. Now, fire tetrahedron, oxygen, fuel, heat. Added, and then you'll add the chemical chain reaction. We must know the reactivity triangle, and that's on page 1067. You need to know this. This is important. The reactivity triangle is oxygen, and you must know that it is the oxidizing agent. Know that. Oxygen is the oxidizing agent. You must know that the reducing agent is called fuel. Reducing agent is fuel. Make sure you know that. And the activation energy source, often but not always heat. And that's the activation energy source, which is heat. I'm going to kind of skip through some of this. I'm going to give you some terms here real quick so I don't forget. Here's one term that I don't think is in your book, but I'm going to throw it out there while I have it in front of me. Whenever we're talking about the reactivity triangle, a hypergolic, Hypergolic, a hypergolic material And that is a material that will ignite when they are in contact with each other. Make sure you write that down. Materials that ignite when they are in contact with each other. Another one I'm going to throw out there, an organic peroxide. Organic peroxide, a shock-sensitive material. Shock-sensitive material. Write that down. Now, some of these things in here on page 1068, and these are 9 reactive hazard classes. And I gave you a couple right there right off the bat, but I'm gonna tell you the ones you really kind of need to read over. Make sure you read over the strong oxidizing agents, and just know that oxidizing agents in the reactivity triangle, that provides the oxygen necessary for a chemical reaction. Okay, make sure you know that. The reducing agent of the fire tetrahedron acts as the fuel. We already kind of went over that, but I'm just kind of throwing it back at you. Know this, on 1068, look at water reactive materials. Know some of these water reactive materials. So look over on chemical examples, and you need to know that some of these materials, such as magnesium, lithium, and sodium peroxide, make sure you know those are water reactive. Magnesium, lithium, sodium peroxide, water reactive materials. Now let's talk about polymerization. Polymerization, I'm on 1069. We need to know this term. You will find it in your emergency response guidebook, and that is polymerization is a chemical reaction where simple molecules combine to form long chain molecules. That is indicated if you look in your ERG, Emergency Response Guidebook, and if you have a P next to your guide number, that means it will polymerize. Let's talk about a catalyst. A catalyst, know this, a catalyst will increase the rate of polymerization and decrease the activation energy necessary to further polymerize. Some of those examples are light, heat, water, acids, or other chemicals. I just went over that you would know that this material may undergo violent polymerization, is subjected to heat, and that it is designated with a P in the blue and yellow sections of the ERG. Make sure you know that. Inhibitor. You need to know what an inhibitor is. An inhibitor, materials that are added to products that easily polymerize in order to control or prevent an undesired reaction. Make sure you understand that term. You will see it again. Just know that under any emergency conditions, terms that you're going to hear from here on out, anytime we're dealing with a hazmat incident, we will always be uphill and upwind of the situation. Uphill and upwind. Radioactivity. First responders need to recognize radioactive material packaging, and we will go over that, and you're going to have to be able to identify it by looking at it. Understand the basic protection strategies if radioactive materials or radiation are present. Some radiation forms are more energetic than others. So, know this, the least energetic, non-ionizing radiation. Least energetic, non-ionizing radiation, that's such as visible light and radio waves. The most energetic, know this, ionizing radiation is the most energetic. You will need to know that, because the ones we're going to go over are ionizing radiation. Know that alpha, beta, gamma, neutron are ionizing radiation. Remember that. Alpha. This is going to be positive charged alpha particles emitted during the nucleus radioactive decay What I want you to know for alpha particles. Alpha particles, they do not penetrate deeply. They are not hazard outside of the body, and alpha particles can be stopped completely by a sheet of paper. Know that. Do not penetrate deeply, are not hazard outside of the body, and they can be stopped by a sheet of paper. Beta. They're faster moving, positive charged. Beta particles penetrate further than alpha particles, but cause less damage over equally traveled distance. Beta particles are capable of penetrating the skin. Know that. Beta particles are capable of penetrating the skin and causing radiation damage. Beta emitters are generally more hazardous when inhaled or ingested. Beta particles travel a distance in the air, but can be reduced or stopped by a layer of clothing or a thin sheet of metal. Gamma. Gamma, high energy protons. Gamma rays are accompanied the emission of alpha or beta particles. They have neither a charge nor a mass, so beta is like a wave of energy. Gamma radiation can easily pass completely through the human body or be absorbed by tissue. It's a radiation hazard for the entire body. Gamma radiation levels vary depending on the isotope and the activity. This is how you shield against gamma. Concrete, earth, and lead. Know that. Concrete, earth, and lead for gamma. Firefighting protective clothing provides no protection against gamma. Neutron. Particles have a physical mass but no electrical charge. They are highly penetrating. Fission reactions produce neutrons along with gamma radiation. Neutron radiation can be measured in the field using specialized equipment. Neutrons may also be encountered in research laboratories or operating nuclear power plants, and that is neutron. Make sure you understand that. Shielding from neutron requires high amounts of hydrogen, such as oil, water, and concrete. So make sure you look over that and make sure you understand how you protect yourself from each different one. Read over, it says X-rays and gamma rays, high energy electromagnetic radiation, commonly referred to as photons. For the purpose of this manual, they are identical and should be treated the same. Just want to put that out there. Radioactive material exposure and contamination. Exposure. Radioactive materials, RAM, emit ionizing radiation. I already told you, you must know that. Incidents involving radioactive materials are uncommon because they are strictly governed in use, packaging, and transportation. So just know that it is uncommon to have an incident involving a radioactive material. Exposure and damage are not necessarily related. First responders will need to know the types of radiation that will cause damage and what proximity or level exposures will cause what kinds of harm. All right, top of page 1073. Need to know this. A person may receive a dose of radiation based upon the length of exposure, energy, and type of source, alpha, beta, gamma, neutron. Need to know that. Exposure to radioactive materials does not make the person or object radioactive. Damage is often described in terms of dosage. Know that. Dosage, indicating the amount of energy absorbed by matter. Contamination occurs when radioactive material is deposited on the surface of skin or clothing or any place where it is not desired. Radiation does not spread. Radioactive material and contamination spread. Let me read that one more time. Radiation does not spread. Radioactive material and contamination spread. Exposure to radiation alone does not contaminate a person. A person may become contaminated internally, externally, or both. And that can enter the body through one or more of those routes of entry. Radiation health hazards. We need to know that this affects the ionizing radiation occur at the cellular level. Make sure you know that, occur at the cellular level for ionizing radiation. Radiation may cause damage to any material by ionizing the atoms in that material. Okay, I'm moving on to page 1074 for protection from radiation. You can read the other part. It kind of goes over the acute effects and chronic effects, so you may want to read over that. Protection from radiation. Because radiation is invisible, it may be difficult to determine if it is involved in an incident. A Class 7 radioactive materials packages should have the appropriate placard or label in transport. If responders note their presence at an incident, they should initiate radiation detection and monitoring. Responders should conduct radiation monitoring if an incident is a suspected terrorist attack or an explosion. So any sort of terrorist attack or an explosion, suspect radiation. So you should be checking for radiation. Or I'm going to throw another one, an unknown. If it's anything that's unknown, nothing that's marked on this, you should actually be checking for radiation. While most incidents involve radioactive materials present minimum risk, it is still necessary to take the appropriate precautions. So, know this is very important. One basic protection strategy uses time, distance, and shielding. You will see that again. Time, distance, and shielding. And you can read over those from decrease the amount of time, increase the distance, and then shielding is creating a barrier. So make sure you read over those. Times, distance, and shielding. Toxicity. Toxicity. Toxic materials may be absorbed into the bloodstream and distribute to other parts of the body, producing systemic effects. All right, so I'm going to give you these terms. Systemic effect, write this down. Systemic effect is damage spread through the entire system. Damage that is spread through an entire system, systemic effect, versus a local effect. A local effect is damage is limited to a single location. So make sure you write those down. Systemic effect, damage spread through the entire system. Local effect, damage limited to a single location. Many pesticides absorb through the skin, distribute to other sites of the body, and produce adverse effects such as seizures, cardiac, and pulmonary problems. Exposure to a toxic material can result in the development of a single systemic effect or multiple systemic effects. Some of these effects may be delayed in a range anywhere between seconds and decades. So, flip over to 1076. On 1076, you're going to see types of toxins and their target organs, which means certain chemicals and drugs, whenever you ingest them or you absorb them and inhale them, whichever route of entry, they will target an organ. So it kind of goes over the different organs that these toxins will target. The ones I want you to be familiar with is the respiratory toxic, and some of those, the chemical examples is ammonia, chlorine. Those are some a little more chemicals that are a little more common out in the field. So know that respiratory toxins, ammonia and chlorine. Also know that some of the eye hazards could be organic solvents. Know that a mutagen, that is a DNA, that's going to be anything from aluminum chloride. A teratogen, That is an embryo or fetus, and that could be lead compounds, or benzene. And then carcinogens could be tobacco, benzene, arsenic, and those things. So those are the ones I want you to know: respiratory, eye hazard, a mutagen, a teratogen, and a carcinogen. Make sure you read over those and understand also the targets, the toxin, the target, and the chemical examples. And I'm moving on to toxic chemical hazard categories 1077. So I'm getting close to my 30-minute mark again. I think I'm going to go ahead, I'm going to do this, and I'm going to stop at the hazardous materials behavior model. So let's finish this. Okay, some of this I don't have to go over because I'll just briefly go over because you should already know this. Asphyxiants, make sure you know this. You're definitely going to see it again. Two classes, simple and chemical. A simple asphyxiant displaces oxygen. Chemical asphyxiants prohibit the body's cells from using oxygen. So a simple asphyxiant might be carbon dioxide because it displaces oxygen. A chemical asphyxiant might be carbon monoxide because it actually prohibits oxygen from getting on your blood cells. So make sure you know those two. An irritant that causes temporary, sometimes severe, inflammation to the eye, skin, or respiratory system. Convulsant. A convulsant causes convulsions, involuntary muscle contractions, can kill the victim because they will asphyxiate or overcome from exhaustion while they're convulsing. Some of those could be organophosphates. And then carcinogens. They cause cancer. You definitely have to know these toxins: asphyxiants, irritants, convulsants, carcinogens. And last one I think is allergens. Allergens. And sensitizers. So know this: an allergen causes allergic reactions in people or animals. Sensitizers are chemicals that cause a substantial portion of exposed people or animals to develop an allergic reaction after one or more exposures to that chemical. Make sure you know those two: an allergen and a sensitizer. Make sure you read over that and make sure you know it. I just went over this part earlier. I'm on 1078. Know that the three common products of combustion, know this: carbon monoxide is a chemical asphyxiant. Hydrogen cyanide, produced in combustion of materials containing nitrogen. It acts as a chemical asphyxiant. And then carbon dioxide is a product of complete combustion of organic materials, and that is a simple asphyxiant by displacing oxygen. So make sure you read over those three common products of combustion and you actually know them. So make sure you highlight that. Biological agents. Biological agents, biological or etological. So just know if you see the term etological, we're talking about biological. These are microorganisms such as viruses or bacteria. They may cause severe disabling disease or illnesses. So let's look at those, and you will need to know this. Always wear appropriate PPE to prevent any sort of transmission. A virus, know this: a virus is the simplest types of microorganisms. The simplest types can only replicate themselves in the living cells of their host. They do not respond to antibiotics. It's kind of like the coronavirus. So make sure you know that. That is the simplest type of bacteria. Bacteria is a microscopic single-celled organism. may cause disease in people either by invading the tissue or by producing toxins or poisons. Make sure you understand that. Rickets. Rickets is specialized bacteria that live and multiply in the gastrointestinal tract of an arthropod carrier, such as a tick or a flea. Smaller than most bacteria, but larger than a virus. Make sure you understand all three of those, because that's something that you will see again. Last one, biological toxins. They are produced by living organisms. The biological organism itself is usually not harmful to people. Infectious disease. Infectious disease caused by reproduction and spread of microorganisms or pathogens into the body may be contagious. It is infectious, so it is contagious. Exposure to a biological hazard may occur in biological and medical laboratories and agricultural facilities when dealing with people or animals who are carriers. Some diseases are carried by body fluids that are transmitted by contact with other fluids. First responders may be exposed to biological agents used as weapons in terrorist attacks and criminal activities. And then it goes into some of the examples of diseases associated with biological hazards that could be a threat. So you can read over those in 1079. Okay. We're going to stop for right now, and this is our third part to chapter 1, or chapter 24.